Hi everyone, and welcome to example problem video number 5 for this course. This video will, or should roughly finish off um, basically all the problems that will show up from chapter 3 in the book. So that includes the first, I think, 17 or 18 problems on this week's homework set should be covered by the first 5 example problem videos that I will have put out, including this one. Okay, today's example problem video is going to be on finding equations of tangent lines using all the tools that we have so far for derivatives. So I've gone over the process for finding equations of tangent lines in the past, but I think that this is an important enough topic that it's worth me making a full video on it. I know some of you guys do not have access to your notes anymore, and even for those of you who do, I think this is a helpful video. So, there's no big formula or anything of the sort for me to write out at the start this time, so let's jump right in with an example. And I'm going to do an easy problem first. No quotes around this one. This is genuinely an easier problem than the harder one I will do later on. And I'll be simply asking to find the equation of the tangent line to the function f of x equals x cubed minus 6. Or actually, let's make this x cubed plus x minus 6 at x equals 1. Okay. Now I'm going to color code these because these two pieces of information are basically what is going to change from problem to problem when you're being asked to find the equation of a tangent line. Basically, nothing else is going to change. Those are the two key things that you need to pay attention to. First off is the function that you are looking for the tangent line to, and second off is the point at which you are looking for tangent lines. Okay, now I'm going to make this small, and I'm going to move this line over. And the reason for this is that the process for finding the equation of a tangent line is always going to be the same no matter how crazy or weird looking the function you're given is. The process is always going to be the same. You are finding the equation of a line. Right? This is not calculus in itself. This problem, finding the equation of a line, is just basically algebra or pre-calculus. It's very straightforward, and there are two things that you need. You need a point that the line goes through, and you need a slope. And it turns out that both of these things that you want can be obtained in a pretty straightforward fashion. So first off, this point here, how do we get the point? Turns out to get the point, you do not need calculus at all. The point is always going to be, in this case, 1. I'm putting that in blue because that information might change. It's worth putting a little arrow here. Since we're looking at the point when x equals 1, we want x to be 1 here in this point. And then the y value is going to be f of 1. And again, whatever the x value that you're given, is the value you're going to be plugging in to f there. This is always the way that you get the point. This never changes. The x value of the point is given to you, and the y value of the point, just you plug in the x value into your function f. All right, where the calculus comes in is where you get the slope. Now remember that the slope of the tangent line is given to you by the derivative. And the derivative where you're plugging in, again, the same x value, in this case, 1. All right, so you need the following two pieces of information. First off, we need to evaluate f of 1. And in this case, f of 1 is going to be 1 cubed plus 1 minus 6, which is going to be equal to negative 4. So this is going to be our y value. And therefore, our point is going to be 1 comma negative 4. Okay, so next up we need to find the slope. And to find the slope, the first step is that we need to figure out what the derivative is. Now, if our function here, f of x, is x cubed plus x minus 6, then you can see that our derivative is going to be 3x squared plus 1. Now we just need to plug in our x value, in this case x equals 1, to see that our slope m is going to be equal to f prime at 1, which is going to be equal to 3 times 1 squared plus 1, which is equal to 4. So we know that our point that the line is going through is going to be the point 1 comma negative 4, and our slope is going to be equal to 4. Now we know that the equation of a line is always equal to y equals mx plus b. And in this case, we know that m is equal to 4, so we know this is y equals 4x plus b. All right, all we need to do now is plug in these two values here into this equation and solve for b. So the next step here, we know that our y value is negative 4 is equal to 4, which is our slope, times our x value, which is 1, plus b. And therefore, we are going to get b equal to negative 8. All right, last but not least, tie all this together into the final equation of the tangent line. We now know that m is equal to 4, and b is equal to 8. And this is going to be the final answer. The equation of the tangent line to the function f of x is equal to x cubed plus x minus 6 at x equals 1 is given to us by y equals 4x minus 8. Okay, so this was an easy problem. I only gave you guys a polynomial to work on this one. Now, the tangent line problem that I gave you guys in the homework for this week is a little bit more difficult. So let's next up look at a problem that looks more like what I've asked you guys to do in this week's homework. Okay, so as usual, with these problems, the only thing that changes are going to be the equation for the function that we're given And then also the point at which you're asked to find the equation of the tangent line. So on the homework set for this week, I gave you guys some functions that require you guys to use the product rule, or rather the quotient rule. So let's do one of them like this. Let's do x minus 7 divided by 3x plus 2. So let this be the function that we're working with. And just to make our life perhaps a little bit easier, let's have this be at x equals 0. Oh, it should also be noted that this is no longer the easier problem. This is now the harder problem. Okay, so once again, our point is going to be 0, comma, f of 0. Whatever the value is that we're told to look at here is the one that we are punching in these two places. And our slope, m, is going to be equal to the derivative of the function that we were given and evaluated once again at x equals 0. So once more, as every single time you ever have to do find the equation of the tangent line problem, we have basically two things to find out and then one equation of a line to determine. So first off, let's do the point. And to do the point, we just need to figure out what f of 0 is. And f of 0 is going to be 0 minus 7 over 3 times 0 plus 2, which is going to be equal to negative 7 over 2. So our point is going to be 0, comma, negative 7 over 2. All right, and just to remain consistent, I'll remind you that this is the value that corresponds to our x, and this in green is the value that corresponds to our y. All right, next up, we want to find the slope. And to find the slope, the first step, as always, is going to be to determine what f prime of x is equal to. And here we see that f prime of x is going to be equal to the derivative of x minus 7 over 3x plus 2. And you can see here that this requires a quotient rule. Okay, so I'm going to tackle this just like I tackle all of the previous quotient rule problems in the example problem videos. We have a top function up here. We have a bottom function down here. And let's write these out. I'm going to call the top one appropriately top of x, which is going to be equal to x minus 7. I'm going to call the bottom one bot of x, which is equal to 3x plus 2. Now let's use a new color for the derivative. How about pink? Top prime of x. If top of x is x minus 7, you'll see that the derivative of that is going to be equal to 1. And if bot of x is equal to 3x plus 2, then its derivative is going to be equal to 3. Okay. So the quotient rule tells us that this derivative is going to be equal to the derivative of the top times the bottom minus the derivative of the bottom times the top. All this divided by the bottom squared. And as usual, let's color code all of these so that we know what goes where. Now we have the derivative of the bottom here, which is in green. And last but not least, the top function over here in red. And plugging all of this in is going to give us our derivative of the function f of x that we had originally. So in pink, the derivative of the top is 1. In blue, the bottom function, mind the parentheses. These are important. Then we have a minus sign. Then we have in green, the derivative of the bottom is 3. Times the top function, mind the parentheses. These are important. All this is being divided by a function squared down here. And this function is going to be 3x plus 2. Okay, we found the derivative, but there's still some work to do here. So let's make this a little bit smaller and move this over to the side. Okay, so we found that our derivative is this 1 times 3x plus 2 minus 3 times x minus 7 over 3x plus 2 squared. All right, we still need to plug in 0. So now, let's use the correct color here. If we plug in 0 into this derivative, we see that this is going to be equal to 1 times 0 plus 2 minus 3 times 0 minus 7 over 0 plus 2 squared. Now this is going to be equal to 2 minus 20 or plus 21 divided by 4, which is itself equal to 23 over 4. This is our slope, m. So m is going to be equal to 23 over 4. Okay, so now that we have our slope, we have our point, I'm going to finish off the problem over here since I need some space. We know that we're looking for a formula that looks like y equals mx plus b. Now, in addition to this, we also know that m is equal to 23 over 4, which means that y is equal to 23 over 4x plus b. And last but not least, we have some values that we can plug in for x and y. And we can do that to figure out what b is. Specifically, we know that y is equal to negative 7 over 2. When x is equal to 0 plus b. And what this means is that b is equal to negative 7 over 2. And now that we have m and we have b, we can finish off writing the full equation for the tangent line. Our slope is 23 over 4, and our y-intercept is 7 over 2. This is the equation of our tangent line. Okay, so long story short, the equation of the tangent line to the function f of x equals x minus 7 divided by 3x plus 2 at x equals 0 is given by y equals 23 over 4 x minus 7 over 2. Okay, this seems like this problem was worse, and it certainly was. This was definitely a harder problem than the first one, but the only reason for that is that the derivative you needed to calculate in order to get the slope required you to use quotient rule in this one. Now, if you are comfortable with quotient rule, if you're comfortable with chain rule, if you're comfortable with product rule, then even doing a derivative such as this one shouldn't be all that much more difficult. Hopefully you can get to that point. That's sort of the goal here. But either way, the overall strategy for attacking problems that ask you guys to find the equation of the tangent line is the same regardless of how hard the derivative is to find. You're always looking for the point. You don't need any calculus for that. And then you look for the slope by taking the derivative and plugging in the point that you're asked for. Once you have a point and a slope, it just becomes find the equation of the line with this point and this slope. That part should just be pre-calculus and should be pretty straightforward. Alright, that's it for what I've got to you in this video, and I'll catch you guys in another one. Bye-bye.